Hey guys, welcome to day 8. Today is 10th of March. It's been over a week, and today we're covering file permissions. So first of all, we start with user management, how to create a new user. Pretty easy, user add command, and then follow it with your name or whatever you want to name your user. And this will create a system generated UID and a GID, as well as set the home directory defaulted to /home/ whatever name you chose, and the shell is defaulted to the born shell. And now you can set a password using password pass wd, and then add the user that you want to add the password for as the argument. And you have to have root privileges for both these commands, so make sure to have sudo in front of them. And there's a bunch of options that you can use with it. I made a table here. And so, for example, if we want to be a lot more specific when creating it, we can just do user add and then add a bunch of options with their arguments as what you want them to be. So here, like, I made it so that the UID is 2004, my birthday, and then G's group ID is the same. Home directory, just change the name a little bit, and then to the default shell to born again. And you can check all of those settings with ID and then username as argument. And next we can use delete. We can delete users with user delete command. We can do group with group add, and we can delete group with group delete. Pretty self-explanatory. And next we got file permissions and ownership. When we list the files, we can use ls with the option L. I've covered this before, right? And then the first letter here, D, will tell us what type of file it is. So in this case, when searching up /home/Richard, it will show us that it's a directory. And here's a list of, we already covered this, but I just wrote it here again, a list for a bunch of different ones. So if it started with a dash, a hyphen, means that it was a regular file, and so on and so forth. But next, this is something new. This is the characters following the file. What is that? So we have RWX. What does that mean? So first of all, we can categorize it to three permission groups. We got owner, we got group, and we got others. This is 1, 2, 3, 1, 2, 3, 1. So basically, this first 3 represents the owner, the next 3 represent the group, and then the last 3, if there even are any, represents other permissions. And then here we get into what the letters mean. So R stands for read, W stands for write, and X stands for execute. And each permission has an octal value. So read has 4, write has 2, and execute has 1. And if it's none, if there's none, then it'll be 0. Usually none is I think none usually has a hyphen as well. So in this example, if you have all the permissions, then you have 7 octal values. If you only have a few, maybe 5 or maybe 4 or 3, depending on what type of permission you have. And you can change the file permissions with chmod. And there's two different modes to modify. They're using chmod, so we've got symbolic. So for example, over here, we can use plus or minus. So here, chmod u, that stands for user, right? So we want to change the user's permission. We want to give them more permission, so we have plus. And the permission we want to give them is RWX, which means we want to give them every permission. So read, write, and execute. And then you have what file it is, right? Oh, yeah, what file it is at the argument. I guess this is kind of like the options. An example, if we want to give all the groups, like all the permission groups, for example, user, group, and others, you want to give them reading privileges, you can do that with plus R. Or if you want to take away others permissions, you go O minus RWX to get rid of all the permissions, right? And numeric mode is pretty much the same thing. For now, I don't know which one's easier. I use a mix of both. But basically it's the same thing, but instead of using like this sort of format, we use numbers. So 777 grants read, write, and execute for everyone, because remember RWX equals 7. And basically the first 7 means the octa value for user, third one is for group, and last one is for other. And once again, the file as argument. So 555 means that we give everyone read and execute, but we don't give them write. And then 660 grants read and write, but not to the others, because grants read and write to own and group, and nothing to the others. And now you can change. Oh, I made a mistake. Let's edit that. Actually, I'll edit later. So anyway, change ownership. Over here, we can use so to change ownership, we can use ch ownership, ch own, or ch group, ch grp. So to change both the owner and the group of a file, you use ch own. And example here is ch own. You have the owner's name with colon, and then the group name, and then the file that you want to change ownership to. And if you just need to change owner, you can just use ch own, the user, and the file name. And to change this group, you can just do change group name, file name. Pretty easy. Next, we've got SSH, which is secure shell. It's very popular for like logging in remotely and executing commands on a Mac computer. And you can use it by using SSH, and then you have the host name or IP address. And I made another spelling mistake to just specify. You can specify the username using user at syntax or the option L flag. Now here's an example, like SSH. If we want to connect to something called a host app called divapp01, we type SSH01 and they'll ask for our password. And then that's pretty much it. And we can use SSH to become passwordless, where you can avoid the password every time you configure. You can just avoid it. And next, we can also use SSH to not need to type in our passwords every time by using something called key pairs, which consists of a private key and a public key. And when the public key is added to the remote server's SSH/authorized keys, the system will grant access to any client possessing the corresponding private key. So to generate the key pair, you can use the following commands: ssh-keygen.t RSA, generate a public and private RSA key pair. And then next, they'll ask you for the file which you want to save the key. And then we can enter the passphrase. You can keep it empty, or you can add a passphrase if you want. Basically, this is just a way to secure the key. And yeah, during this process, the public key will be stored in //richard.ssh/id/rsa.pub. This pub means showing that it's private, and then the private key will remain in the not public version. And to enable SSH login, you just copy another spelling mistake. Copy your public key to the remote server with SSH copy ID and arguments such as Richard@fan. And next we got SCP, which stands for Secure Copy. This is a powerful tool for transferring files and directories securely over SSH. So it kind of acts like the copy command in Linux, where you can copy a file. So for example, we got Richard code tar.gz from our computer. You can copy it to the same directory on a remote server. So how can we do this? Is we can use SCP command with our path to the file, and then with the remote server and where we want it. And then it'll prompt us with our password, and then that's all it takes. Now if you want to transfer entire directories, you can include the R option, copy recursively, and if you want to maintain original file ownership permissions, simply add the p flag. And yeah, that's file permissions. Thanks for watching. See you guys tomorrow. Peace.